Hello and welcome to lesson 4. Today I'm going to be talking about the shelf tools up here and up here. We have these two different shelves and I'm just going to be going over a few of the default shelf tools that Houdini provides for us, as well as how to make your own, and then I'm going to talk a little bit about Houdini digital assets, so how to create them and manipulate them. So we have these different tabs to separate different sorts of operations that the shelves can do. So the first thing I'm going to do is get rid of this gnomon here. So if I press D while hovering over the viewport and unchecking origin gnomon, I can save this as the default. So now every time I open Houdini, I won't see it. Okay. Alright, so we've already went over these shapes here. So again, if you hold down Control and click on any of these shapes, it's going to create them. And actually, a lot of these shelf tools sometimes only lay down one node, so they're just kind of shortcuts. I'm not sure if it's just a depreciated way of doing things or simply an alternative to laying stuff down in here. So for example, if I put a null down, hold Control again, all we get is a default null. So it's the same thing as if I press tab here and type in null. So we haven't really talked about lines in Houdini yet, so these are basically just curves. So if I press this button for line, I'm going to hold Control again so that it puts it in world center. We have a line object here, and this is just a straight line. And if we visualize the points, we have one at the bottom and one at the top. What I can do here is resample, which will give me more points along the line. I can control this by this slider over here. If I lay down a VOP, for example, I can apply noise to this line. So let's go through the same operation we did last time with our VOPs. I'm going to put a turbulent noise along with an add, and we're going to add our original position to the modified position, and here we have a noise. So let's promote our frequency parameter to the top, and if I put an expression here, $f, I'm going to toggle the real-time view, and here we have our noise being applied. Pretty frantic, but let's move on. So next up is a circle, which is just basically the same kind of geometry as our line, except it's a circular shape. It's currently a polygon, but we can switch it to a NURBS curve or a Bezier curve, and we still have this polygon in the middle. And this can be easily gotten rid of by using an ends node. So if I put that down, and by the way, if you have a node selected and you lay down your modifier, but if you now hold shift and press enter, it's going to lay it down and flag it for you automatically. So in here I have to go to unroll, which will get rid of our polygon. Next up we have a curve. So here we can interactively draw a curve. So if we lay down points, it's going to make a curve for us. If I press enter, it's going to execute it. And if we dive inside, we can change this to a NURBS curve or a Bezier curve. Unfortunately, right now, Houdini does not have handles like you might find in something like Cinema 4D. I'm really hoping for this feature to be added to Houdini in the future. Next up is path, which is still a bit of a mystery to me, but basically it seems like it's somewhat similar to a curve. But it seems to be laying down these separate objects here for each of the points. And we have a series of nodes here. Okay, I skipped over draw curve, which is basically a manual way to make a curve. Next up is spray paint. So if I put down a sphere while holding Control, Gonna go inside and change it to a polygon. And if I use a spray paint, we can spray points onto the surface of our object. In here, we can visualize as spheres or not. So now we get the points that we spray painted. Next up, we have font, which is pretty self-explanatory. I'm going to hold down Shift again. And by default, it gives us the frame number. We can change our font. Let's say to Helvetica. And if you want to extrude this, just lay down a poly extrude. And here we have some 3D text. Don't forget to output the back to get our front-facing polys. We also have control over the tracking and font size and so on that you'd get in any design software. Okay, so next up is platonic solids, which we went over already. So this is same deal as the previous lesson, just lays down this platonic node. Next up we have L system, which is handy for making tree-like structures. So we can make this either into an object comprised of these lines or curves, or we can make it a tube, which will transform it into geo. And we have these various controls over generations, scale, seed, and so on. Next up we have metaball, which is basically a sphere that kind of welds itself to other metaballs. So if I hold down Alt and make another one, maybe shift this one, I'm going to press T for a translation gizmo, shift this one over, merge the two, like so. And as you can see, they're sort of welding in between each other, like so. And finally we have file, which is basically the same thing as the equals shortcut. If I lay this down, we get our browser and we can load in any geometry we want. So that's it for the Create tab for the first shelf. Next up is the Modify tab. So if you hover over any element within Houdini, there's usually some kind of explanation or at least the title of the tool that pops up. So each of these shelf tools has that, and we have a description here. So for example, this combine merges the geometry of multiple objects into the last selected one, and whenever you see press F1 for more help, we can get this menu for our documentation. And sometimes they even have example HIP files. In this case, we don't. But basically, this first tool merges two objects together. So, say I put down a sphere and a torus. We select both of them, click Combine, and now we only have one object, and it merges them together. Extract creates a second node out of an object, and it uses a node called object merge to put it in, which I haven't talked about yet, but it's very, very handy within Houdini, especially when you have dependencies and you're trying to transfer one object into another node. So say I have a torus again, and I'll extract it. So now we have a second object node here. And here we're using an object merge, which basically fetches geometry from another node into our new one. So this is basically a copy, but now we're inside another SOP network, which is super handy. Gonna get rid of this. Next up is mirror, that creates a duplicate of our object that is symmetrical in our world space. So if I take this torus and move it along the x-axis and I press mirror, and here it says select one or more objects, then press enter to continue. So I'm going to execute that, and here we have a second torus that is offset by the same amount in the other direction over here. I believe this only works on the x-axis. So next up is the copy to points, which I went over in a previous lesson. So this pretty much instances an object onto a set of points. So say I want to instance a sphere. Let's scale it down. And we already have it selected, so I'm going to run this shelf. Now it says select the geometry on whose points to copy data, so I'm going to select torus and press enter. And now we have our spheres instanced onto our torus. This puts it down inside our sphere and gets rid of our torus object. It brings them both into the same SOP network and executes the copy to points. Duplicate makes a copy of our selected object. So now I have the same thing, and you can click it as much as you want, and here we have 3 copies. Align components aligns an object to one facet of another object. So let's make a rubber toy and a platonic solid, which again we can use this shelf tool for. Let's put it over here. Gonna make it a bit bigger, make it into an icosahedron, and go up, and say I want to align our rubber toy to one of the edges here. So I'm going to select my rubber toy, go back to modify, and align components. Let's align it to this point of our platonic solid. We can also align it to an edge or a primitive. So first we're being prompted to select a source component on the object to align. So I'm going to try to align the base of our rubber toy. So let's pick this point here. Now select a destination component. So I can align this to any other object or even itself. So if I click this point here, it's going to snap the point we selected initially to the second point inside of here. So this makes all the transformations on the object level here. So next up is match transform, which transfers the rotation, scale, and position data from one object to another. So I'm going to put down another rubber toy and a torus. And then I'm going to move this torus to a random location and rotate it like so. And by the way, if I press R, I can free rotate it if I don't click explicitly on any of these axes. So now say I want to transform our rubber toy to the same position, rotation, and scale as our torus. So I'm going to select the rubber toy, run this shelf tool, match transform, and here we're prompted to select the object to match, so we're going to match the torus, and here we go. The rubber toy has exactly the same values as our torus now. So next up is move pivot to center. So say I want to deform some kind of geometry, like a torus. So if I go into my point selection mode and select a few points by holding down Shift, now I'm going to press T for transform, and all these points are going to be transformed, and if I hover over the middle here, it's a free transformation method. Okay, so if I put down a bound SOP, this is going to give us our bounding box of the object. So if I plug my torus in here, we're going to have this bounding box, which calculates the volume of our object and creates a box around it. Now if I plug this into the bound, we have a completely different looking bounding box because our points have been deformed. So this move pivot to center moves our pivot point to the center of the bounding box. I'm going to go back into our torus and delete our edit. And if I put down a transform SOP, we have control over our pivot point. If I press the apostrophe shortcut, we have control over our pivot point, and our object is disconnected from it. So next up we have a command that moves the center to the pivot point, so center of the bounding box to its pivot. So I'm going to put down a torus once again, and put down a transform SOP. And if we flag this, I'm going to again move my pivot point by pressing apostrophe and moving our pivot point somewhere. And if I go back up one level and hit move center to pivot, it's going to create another transform SOP to move this pivot point back to the center of our bounding box. Next up we have this freeze tool, which basically transfers our transformations from object level to SOP level. So I'm just going to free transform this torus, maybe rotate it around and scale it up in the X. And if I run this freeze, it's going to move my pivot to the middle. And here it's going to lay down a transform SOP and copy all of my manipulations into here. I'm going to skip the bake animation, and delete basically does the same thing as a delete SOP. So I'm going to go in here and maybe select some points. And by the way, if you hold right mouse button and go to area select visible geometry only, it's not going to select what's behind our object, just what we see here. So if I choose these points and press delete, it's going to lay down a blast node and do the same thing. Now this hide basically just turns off our display flag. And parenting is pretty self-explanatory, so if I take this null and if I select the parent, it's going to run our parenting. Okay, so next up is some modeling tools. I'm not going to go through all of these, but I will do a few. So first up is revolve, which revolves a curve around a center axis to sweep out a surface. So let's go back to create, and I'm going to make a curve. I'm going to press space 3 for our front view, and I'm going to make this shape. And I'm going to press space 1 back to our perspective and run this revolve on our curve. And here we have it. We have geometry that sweeps around our curve. I'm going to get rid of this and run this loft on our same curve, and that creates geometry in between our points. I'm going to skip rails, but here we have a sweep which can create a surface by sweeping cross sections along the backbone. So if I put down a circle and maybe scale that down, I'm going to sweep it along my curve. So let's select our circle, press sweep, and select our backbone, press enter. So now our circle is being swept along this curve. I'm going to scale it down even more. And this instances our sphere on every point, so I'm going to again resample our curve to put more points on it. Let's see the provided hip file that comes with the sweep operation. So if I press F1, we have our help menu, and usually you find the hip files at the bottom, so I'm going to scroll down and launch this first one. So here we are, and this is actually a better example of our sweep. So every provided hip file usually has this collapsed object node, which by the way is made with this button or the Shift-C shortcut. So say I have a torus in a box. If I select both of them and press this, we have a subnetwork. And here we have the torus in the box. So this is a good way of organizing and collapsing our elements. So now in this sweep basic example, we have a basic curve here, a NURBS curve. It's being converted to polygons, and this circle is being swept along it like so. It's being scaled with an expression, which grabs the current point, adds 1 to it, and is multiplied by 0.03. So it gradually gets smaller and smaller the more the points increase. So let's see our point numbers here for this element. So at 0 we have a small circle, and it gets bigger as the numbers go up. So after this sweep comes a skin SOP, and this creates geometry on the surface of our circle. And then we cap it to fill in our geo at the end. And that is that. Let's close our session here. Next up is the ray operation, which is sort of a projection tool. It projects one surface onto another. So say I want to project a torus. And I'm going to go inside and rotate this in the Z. And I'm going to try to project this onto a rubber toy. Let's move this over. And maybe scale it up. So if I select the torus, run the ray, and select the primitives to project on. So I'm going to select the rubber toy, press enter. And now our torus is being projected onto the rubber toy. So if I template my transformed rubber toy and move the torus around, it's going to try to stick to our rubber toy. Next up is a Boolean operation, which can cut out one geometry out of another, or it can unify them. So let's try to cut a torus out of a pig head. I'm going to lay down a pig head and a torus. Let's just make this a little bit thinner and maybe move it over here. Let's go up, and we need to select the first object to run the Boolean on. So I'm going to select the pig head, click the Boolean. Now we need to select object B. So I'm going to click on the torus and press enter. And now the default Boolean operation is intersect. So it cuts into the pig head, but keeps the torus. Other operations here are union, which merges the two, and subtract, which basically creates this little tunnel in our pig head. As you can see, our two object nodes have been merged into one, and the Boolean operation is run inside our SOPs. Shatter can fracture an object, so I'm gonna just keep my pig head here so we can fracture it. And let's run this operation now. And so what happens here is 3 nodes are laid down. First one is an ISO offset, which creates a volume. Next up we have a scatter SOP, which scatters some points inside our volume. And the Voronoi fracture SOP creates these fractured pieces for us. We can lay down an exploded view to see exactly what's going on with our fractures. This is good for creating RBD sims for breaking objects. This is an older method of doing this. Houdini 17 has come out with an RBD material fracture SOP, which I won't go too deeply into, but basically it replicates certain kinds of materials breaking. So you can choose between concrete, glass, and wood, and it creates different pieces all inside the SOP. So basically all these operations and more are combined into here. And you can add detail with chipping and interior details. So let's plug this in here to see what it looks like. It's quite a heavy node, so it takes a bit to calculate. I'm gonna plug this into our exploded view. And here we have this sort of thing going on. Gonna switch my lighting mode. And back in our pig head, I'm gonna uncheck this add shader so we can see our internal geometry. So if I enable edge detail, we're going to create this noise on the edges here, which gives it a more realistic look than we had in this method. And I can go ahead and check this interior detail, which creates this sort of randomness inside of our geo. Usually the next step is to create a constraint network, which is done automatically for us in this node. So to visualize this, I'm going to put down a null and add it to this constraints output. So these lines basically connect our pieces together, and then we can use this in our simulation to keep the pieces together until they collide with an object. Next up is our topo builder, so I'm going to get rid of our shatter things. Now with the topo builder, we can actually overlay geometry on top of our mesh. So I'm going to click topo build, get our lighting back, and it says to select projection geometry. I'm going to select it, press enter, and I'm not extending anything, so I'm going to press enter again. And now I can draw polygons, which is going to stick to my mesh. This is good for retopologizing geometry. So if I press enter or escape, we can see that our primitives are sticking to the surface of our pig head. I'm going to go back in here and turn our shader back on. I'm going to flag our pig head off for now and put in a line like so. I'm going to put it here. And the next tool is the refine. So if we select our line and press enter, we have control over these points here. And this increases the number of points in a curve or surface without changing its shape. We can also sculpt on any object we want, so let's try it on the pig head. I have the pig head selected. I'm going to click on Sculpt, select my pig head, press enter, select the faces I want to apply it on. So I'm going to double click to select everything and press enter. And now I have this sculpting tool, which I can use to deform the geometry on my pig head. And here we have control over how it's deformed, the various parameters of my brush, and we can also put on symmetry. So if it's reflective, anything I apply, it creates symmetry on my pig head. This is more obvious on a sphere, so I'm gonna lay that down, make this into a polygon mesh with maybe more subdivisions. And let's run the sculpt on it, like so. Let's click on reflective symmetry, and here we have a symmetrical sculpting operation. Next up we have scatter, to scatter points onto a surface. So let's select all our geometry, and here we have some points scattered on this. I'm going to go over some scatter operations in the next tutorial. We can make use of this group function to select points, primitives, edges, or vertices to put them all into a group. So we went over how to do it manually inside SOPs, but this shelf tool lets us do it in fewer clicks. So I pressed enter on a selection and it created a group for us. The edit node simply puts down an edit node where we can manipulate our geometry. Visibility can show or hide primitives in the 3D and UV editor. So whatever I select and run visibility on, it's gonna make it invisible, but the geometry is actually still there. Next we have polygon modeling operations. So I'm gonna get rid of our sphere and explain the poly draw tool. So as soon as we click it, we can make these primitives and build a mesh manually with it. I've already went over poly extrude, but this shelf tool does exactly the same thing. Here we can output our back. I'm gonna undo this, and bevel I've already went over, which bevels the corners. I'm gonna lay down a torus again to demonstrate the other shelf tools. And here we have poly bridge. It creates flat or tube-shaped polygon surfaces between source and destination edge loops. So I'm going to demonstrate by selecting some primitives on this torus. And if I hold down A, I can actually use a loop selection mode. Let's get rid of all of these polygons. And we can use the poly bridge tool to bridge two facets together. So I'm gonna run this command and go into my edge selection mode, select this one, press enter, and here we can select the bridge destination. So let's select this adjacent edge. Press enter, and here it creates a bridged geometry. You can put the divisions down, and here we have it. Poly split can cut our geometry like so, however you want. So this creates a new polygon. Edge loop can cut edges based on a loop, like so. This is good for creating control edges when you want to subdivide geo. So say I put a subdivide here. So let's try this on a box and run the edge loop and put a control edge over here. Now if I put a subdivide on this box, it interpolates between our points on the top but not at the bottom because of my control loop. Poly reduce reduces the number of polygons on our geometry. So let's go back to our torus and get rid of all this and run our poly reduce on all of these polygons. Now if I change the slider, it's gonna truncate our geometry. Next up is poly fill. I'm gonna demonstrate this by using a clip node. And this basically clips any geometry below or above it. So here we're clipping our torus halfway, and we can change above or below like so. And if I put down a polyfill on this edge and this one, it's going to fill in the torus here. Collapse will collapse edges or polys. So if I select this polygon here and press enter, it's going to collapse it to one point. Edge flip will change the directionality of an edge. Divide will create more points along our edge. So if I turn on my point visualization and run this edge divide on this edge, it's going to create points. I'm going to undo that, and dissolve gets rid of edges. Clip basically does the same thing as our clip stop here. And subdivide will subdivide our geometry using a variety of different algorithms. So I'm going to run this subdivide on all these polys, and it creates more geometry for us. If we pick open subdiv bilinear, it's not going to interpolate between our edges, but it's going to just create more geometry inside of our polygons. So this smooths it out, and this keeps the faceting but creates more polygons in between. A facet stop has a variety of functions, so if I run this on everything, we can manipulate our normals and reverse them. And this has a variety of different other functions to optimize our geometry. And this fuse tool is going to merge our points together. So if I run the fuse and select some points, for some reason it doesn't actually select the points. So if you go into this group field and press this arrow, you can select them here and press enter. And this is going to fuse them together by sliding this snap distance. And this will run a smoothing algorithm on our geometry. So if I select it and run it on everything, it's going to make our geo smoother. Next up are deformers. So if we run a twist, we can define our starting and ending points and twist our geometry around. Next up we have bend. And we can do the same thing, start and end. And we can use this bend. We have a taper tool. Do the same thing. And these are all basically the same tool that apply transformations to our different parameters here. Fractal and mountain are pretty similar to each other, so this just applies noise to our points. I'm going to select all my primitives and apply this, and it creates this sort of noise. Whereas a mountain will create a 3D noise. And we can manipulate these parameters here to make some interesting looking geometry. Waves creates an ocean-like surface, so this is part of the ocean tools. Going to put a grid down to make this more apparent. Let's scale this up and create more subdivisions and run our waves. So if we press play, it's going to make an ocean for us. We can control the look of it by going into our ocean spectrum node and putting down this grid size. And change the look of it like so. Let's make this grid bigger. Say 100 by 100. And here we have a better idea of what these stops are doing. Let's create more subdivisions here. And this is a very uniform look, but again, you can tweak these parameters to your liking. Next up is ripple, which will execute like so. We're going to select everything. And put up the height and wave decay down. And here we have a ripple effect. And here in the texture tab, we have these different UV tools, which I won't get into now. We also have tools for rigging, muscles, characters, constraints. I just had a crash, so I'm in a new session now, and now we're on the constraint shelf tab. So one handy thing here is the look at function, where we can constrain an object to have its axis always looking at a certain other object. This is useful if you want to point your camera at something regardless of its position. So I'm going to lay down a camera and a null. So what we want to do is point this camera at the null regardless of where it is in world space. I'm going to select my camera, press look at, and select my null, press enter, and lookup object, we don't have any. I'm going to press enter again, and now we are constrained to this null. So if I select my camera and move it, like so, it's always going to be pointing at my null object. Now if I move my null object, the camera is going to follow it. Follow path is pretty similar, so we can have an object follow a curve. Just gonna delete this, put down another camera. And here in create, I'm going to make use of this curve. And I'll draw this very random curve. Press enter. And here I can change it to NURBS, so it interpolates. Now select my camera, go back to constraints, run the follow path, select the path object, press enter, no look at object, and no lookup object, and now we have our camera animated along this path. We can also have it looking at another object while it flows along the path. So I'm going to put down a camera again, put down a null, draw another curve, make a NURBS, and I'm going to select my camera, run the follow path, select my path, press enter, look at object will be null, no lookup object, and here we go. Now the camera moves along the spline, but is constrained to the null. If I go up and move my null, it's going to keep looking at it, regardless of where it is on the curve. I know I'm skipping over some of these shelf tools because I want to keep this lesson fairly short. So basically the next 3 tabs are functionality for hair, which I'm not going to get into. These are terrain tools, so these are basically different presets for terrains. Let's just lay one down to see what it looks like. Let's try an island. So that took about a minute for me to execute, but here we have our island. And by the way, if you're ever lost in this object context, if you press F, it's going to frame all your nodes. So in here is a preset using Houdini's height field toolkit, and all of these nodes are making up this island setup. Let's move on to our cloud shelf, where we also have presets using Houdini's cloud tools. Let's lay down a simple cloud here. And we need an object to turn into a cloud. I'm going to put a sphere down, make it a polygon mesh, and put a mountaintop on it. I'm pressing space G to frame it. And let's make this a bit of a crazier shape and apply our cloud to it. So here we have a cloud node that turns it into a volume, and Houdini has a set of tools to manipulate the look of this cloud. Let's try the sky rig. And here we have a set of clouds that we can use for a sky. Here we have some volume tools, and some plugins come with their own shelves. So I have Redshift installed, and here are various Redshift operations to put down lights, parameters, run the render view, and put down our ROPs. I also have a set of tools called MOPs, which stands for motion operators, and these can execute a variety of motion graphics looks within Houdini. You can make your own custom shelf tools, and I made this tab myself, which you can do by pressing this plus button and choosing new shelf. You can name it whatever you want. Accept, and here you have a new shelf that you can populate. I'm going to delete my shelf tab, and here on my custom, what I have here is a cyc that I made by basically bending a grid for a background, and I also have a link to Substance Painter. So whenever I click this, it opens up a port where Substance Painter can talk to Houdini and import textures directly into my shop or mat networks. All of these shelf tools make use of Python script, and you can see the underlying code by right-clicking on any of them and going to Edit Tool. Here under our Script tab, we have our Python that executes our tool. So if I want to make my own shelf tool, I can right-click and click New Tool. Here you can write your script from scratch or copy it from somewhere else. And here you can name your tool whatever you want. So in the label we can put my tool and accept. And here we have Nye tool. Okay, let's delete this. And the easiest way to create tools is simply to drag a number of nodes right into our shelf. So let's make a lighting setup. I'm going to go over here and choose area light while holding down Control, and this conforms it to my viewport. I'm going to lock it and put it wherever I want. So this can be our key. I'm going to Control click area light again. This puts down a second area light. I'm going to move it over here for our fill light. Let's put a spotlight down for a backlight. Move it over here. And now maybe I can add a camera. Control clicking once again. And I'm going to orient it over here so it fills the background. And maybe I can put it in a placeholder object. So let's put down the trusty torus. We have it here. I'm gonna move it so it's sitting on the floor. And now that I have all the nodes that I want to create for a shelf tool, I'm going to select any number of them, and I'll include my cyc in here. So I'm going to select them and just drag them up into my shelf, and this creates a new shelf tool. Let's name it Light Setup. Copy this in here and accept. So here we have a light setup. So if I delete all of this and click on this, it's going to lay down all my nodes. I'm going to delete my new tool. And now it's time to go over our right shelf.